All right, so yeah, I'm just going to start over. I also have a backup machine running on EC2, just in case. Don't fear, my friends, don't fear. All right, I'm going to talk about data science and visualizations in Angular. Okay, but that's a terrible title because I'm not actually talking about that, as you may or may not already know. Let's come back and rename this talk later in the talk. Before I forget, this is me, and that's you. I have a dog. She's very funny. She might be getting surgery on Friday. It's really kind of unfortunate. I write some books. We always keep these books up to date, which can be challenging to say the least. Okay, so let's talk about smarter web applications for real. In our world, data is everything. We do a lot with data, right? Like we look for where our users are on our website, you know, what people are interacting with, all that fun stuff. Geez, I feel like I'm in a time warp. Like I feel like I've done this before. You know, data is kind of important, but it's only meaningful when there's action that's associated with it. All right. Okay, here we go. So this is kind of like some of the data science that we do in my work. Yes. Okay. Challenge 2. All right, it worked. All right, so what I just did here is just went to Google Analytics and made an API call and fetched my analytics profile as for these two guys right here for fullstack.io, which is the name of my company, and ngbook.com. And here I'm going to make a request to see the Google Analytics data for the last day with these metrics and some of these dimensions. So we're looking at right now, this is primarily a content data about our site, like what are the page views, the time on the page. Obviously you can see that. So let's dig through this and see if we can't discover some information. Let's see, with Google Analytics, we get a referrer with every single event, or with every single API call. These are aggregated API calls. Sorry, Google aggregates their events on the Google Analytics API. So these are all aggregates. Also, to protect some of my company's information, this is fake data. So Johnson.com does not send us, or maybe they do, but we won't discover if they do in this data set. Okay. Cool. So these are the top 5. These are the top 5 potential websites that send us data. And you can see here we're looking for the referrers who send us unique users, unique readers to our application. It's pretty cool. Why would you maybe need to do that? Well, because what if we want to reach out to Johnson.com and be like, hey, do you guys want to collaborate? You want to do something together? That'd be kind of fun. Let's also look at where our users are. We can do that. Google gives us the ability to query where a user has made their API calls. Let's go ahead and look at the top 3 countries that spend the most time on our site. Wow. Certainly looks like the United States almost doubles the amount of time that India spends on our website. Let's actually see what the top 5 are. Germany and Brazil. If you guys are from any other country, you should be spending a lot more time on the site. Why is what? Because this is for time on page. If we want, we can look at unique page views. Does that feel better? Okay. Okay, so what content are people really devouring on our site? we can look at the paths that were being requested, and we can see how much time people are spending on the different paths. It looks like right now the blog page is getting a lot of time. And lastly, we can also do things like chart this data so we can kind of understand it a little bit more. This is stuff that that we do pretty much pretty often. I mean, all day. Okay, and lastly, actually we already did all that. Okay, I lied. We actually need to make that request. There we go. All right, cool. So we can see that the number of page views in the United States is pretty much half the world. This is all for yesterday, by the way. So it's all yesterday's information. Okay, so that officially took, how much time do I have? Like 30 minutes, 25 minutes? That officially took 20 minutes to go through all that, including the time that we did before. Isn't there another way we could do that? Can we do this? Can we do this shorter? Do we have to take all that time to investigate our data? Well, we could use something like Mechanical Turk. You guys know what Mechanical Turk is? It's a service that AWS hosts that allow workers to join and do tasks that you can submit to them. So, like, send them a whole bunch of images and say, is there a dog in this image? But that's not really cool, and that might take more time. We have to train people to do stuff like that. I argue we could use machines that don't fail on us ever, especially in critical presentations. Okay. One of the reasons I argue that is because computers are they're pretty awesome at doing things repetitively in an automated way. We can program algorithms so that they do the same thing in the same repeatable, in the same process as they did them before. What are humans not really good at? Well, being consistent, doing things on time, doing things automated, getting Docker to run. So I say we should use computers for the hard stuff and leave the fun stuff to the people. Woohoo! All right, so we've come to data science. I argue there's a lot of different definitions of data science. My favorite one is that the data science is the science of exploring data through storytelling. So because of that, I say, well, why wouldn't it be, or why do we humans have to do stuff we're really bad at and computers just have to do everything that we ask? Wait a minute, that sounds awesome. Wouldn't it rock if our apps are Angular 2 apps and well, I'm specifically talking about Angular 2 apps. Our Angular 2 apps, wouldn't it be awesome if they knew what to show to who they wanted to show it to at the right time? Wouldn't that be awesome? This one isn't a screencast. You can say, thank you. That'd be awesome if they could do it automatically too. That'd be pretty sweet. We could, I would argue, maximize our conversion rate and minimize the amount of work that it takes for us to keep that up. Because we don't have to be the ones who update our components all the time and redeploy and test and hopefully cross our fingers it works. So, like I said, we would come back to the talk title. Let's do that right now. This talk is officially now titled, Building Smart Angular Components Through Data Science. Please welcome Ari Lerner to the stage to talk about building smart Angular components through data science. Okay, so I think there are 4 steps to make this awesome. 1, we need to create our components. Unfortunately, computers can't do that for us yet. Then we'll create an environment for our components to run where we can both set out goals that we want for our components to strive for, and we can track the usage of those components. 3, we'll want them to analyze the data and update the application on the fly. because I don't want to be involved in that. You probably don't want to be involved in that. So, yeah. So we'll do all of this automatically and atomically, except for number 1. We have to do that for right now. Okay, let's look at a simple example. Let's say that we have a landing page, and this landing page has a bunch of little components on it. For instance, a header and description, some sign-up boxes, maybe a special sign-up box at the bottom because there's a special offer for people who make it all the way down to the bottom of the page. This is very fairly straightforward. For the purposes of our discussion, I'm going to shrink that down instead of to be all those elements. We'll have that be 3 elements. And we'll use a directive that I'm calling Smart Stack to say that we have an experiment and it wraps all the directives, all the components underneath it. Whoop. Okay, so we're going to use this very fancy landing page as an example. All right, so this is that site running with a little bit more text. Okay, so what does the Smart Stack directive do? The Smart Stack directive acts as a communication layer between our machines and our host, our server. It registers and maintains an experiment, and it is the one who's responsible for populating the components, as we'll see in just a minute, and it maintains a list of variants. This slide should be split in 2. So, basically, that's actually okay. The experiment directive here, like I said, it registers an experiment. That is terrible. It registers an experiment, and every single, when it's ready, when it gets the OK go, it places all its variants on the page, as we can see right here, using the view container provided by Angular 2. Whoa. All right. Now everything seems to be crossing fingers, everyone. All right. All right. So let's talk about what each one of those components has. By using the smart variant component, oh, you know what? Let's actually look at the demo. So we have this landing page here. I have those 3 elements up there, and each one of these 3 elements is a smart variant, as it said, as we looked at in the source. The metric that we're tracking here is the number of clicks, because it's really easy to demonstrate clicks in a presentation. There's other things that we can track. So I'm going to click on this sign up box a little bit, a few times, and nothing is going to happen on the page, because what I don't want to happen is I don't want a user to be putting in their email and then the sign up box moving to the top. Oh, by the way, I should probably say this, the purpose of this demonstration is to say how can we organize the order of our components on the page in the most efficient way to maximize the conversion rate, to maximize the interaction between our site, our application, and our users. So what I'm interested in is where should the sign up box go in this page. So as the user is clicking around on the site, we want to register and track that information so that the next time that a user in the same area, in the same segment, gets a more optimized version of the page rather than the previously unoptimized one. And notice that I clicked on that a whole bunch of times, and the sign-up box was prioritized and is now in the middle, and all the testimonials sadly had to go below. Okay, so the way that is working is I'm using this track function inside the component that every single time that I'm clicking on that, it calls out to the parent component, which contains the experiment with any metric that I'm interested in. In this case, I'm just sending a metric that says goal is true, indicating we've reached the goal. So let's take a quick look at the stack. In the front end, we're using, obviously, Angular 2, as well as a little bit of custom TypeScript. In the back end, we're using Google Analytics, also using a node server, both as a proxy to and from Google Analytics. I'm streaming this through a log aggregate manager. I really should know what that title, what their subtitle is, called Kafka, and analyzing it with Spark and IPython notebook in this case, with scikit, cite and scikit-learn. And then I'm shoving it back into Mongo, where the node server then can serve requests for our front-end application. And we've already seen the Python. OK, cool. Great, so let's talk about machine learning real quick. I'm going to speed up again. OK. So ideally, we want to find features in our data set that correlate to something in the real world, right? Like an example of that might be, well, if we have a bunch of users in India who come and search and read our news at night in their evening, I want when somebody comes to look at the site in India that we maybe present them with a special offer that says, hey, pops up a new component and says, hey, this is seriously just for you, when somebody in England might not get that same offer. These are ways that we can make our applications more compelling and more dynamic for our users. So some features that we can track are things like, from our users are things like country, the time of day that they're looking at, the amount of time that they spend on the page, and a bunch more. Like things like, do we have any Facebook information on this person? That's creepy. And then we can see if it maps. If it maps over to any of our page goals. So our page goals are things like clicks and scrolls. How do they scroll down? Are users scrolling down to the bottom of the page? If so, we want to know that so that we know that the sign up offer box on the bottom actually does make a difference. Also, one of the ways that so there's this machine learning experiment that teaches, you've been all over Hacker News, that teaches a computer how to play Mario. It uses something called Q-learning. Q-learning, we can treat our components just like they're competing in Mario, where we say their components are competing against each other. That's, and one way that we can do that is by tracking how often they render and which ones get the interaction and which ones don't. And that's another way that we can prioritize and show the components that matter to the user who's interacting with our application. And things like mouse movements and other things like that. In this case, we are using k-means clustering and a little bit of linear regression in this very demonstrative demo. And what we get from that is a model for predicting the highest user interaction for the current user who's looking at the site. So this is kind of like a variant to A/B testing. However, it's more reactive A/B testing based on context of the user who's interacting. Coupled with Angular's dynamic rendering engine, we get a page that presents the right information to the user, to the right user at the right time, based on an aggregate amount of data that is we're gathering from our users who are looking at our page. Okay, real quick, take a trip with me.
Can you zoom in on the slides?
What?
Zoom in.
Oh. Nope. I can try. Let's try this. Is that better? All right, sweet. So take a trip with me. Thank you. Do you guys enjoy that as much as I did? Okay. let's not go that far. Let's come back. Unless you're going on NG Cruise. If you haven't heard, we're going on a cruise. Okay, so what this stack is doing is it is tracking the information about how well components are performing for the interaction of users worldwide, and we're storing that information, and we're building a model for how to approach optimizing our components so they automatically maximize our conversion rate. And when I say conversion rate, what I really mean is user interaction. So it doesn't matter if you're selling something or you're not selling something. What we're doing here is we're tracking how well these components operate as independent atoms on our page. So if we have a ton of components that are doing this, we can tell before we even start writing our code what components will perform well for what purpose. Did that just blow your mind? Because it totally, I was like, I can't believe that's what we're talking about. That's awesome. Because what that means is that we could build components as isolated units, and we can allow the page to develop itself based on the ideal goal that we want the page to, how we want the page to perform for us. Automatically. So in the future, if we do have a lot of this data, in the future we could be building apps by just telling a computer that we want to write the content, or just giving it some content. Or do we? Maybe we could just use NLP. Any questions? I'll be here all week. Thank you.